Last section, Unit 8, moles, molar volume, and molar concentrations. So now we need to look at some more complicated things, ways we can use moles, how it is important for us. Okay, first we're going to look at molar volume. So one of the things that Avogadro did was he worked very hard on how gases interact with each other and what happens when we have the same amount of gases at equal pressures and volumes and all sorts of things. But basically what it comes down to is this, that the molar volume, so if I have 1 mole of a gas at a system called SDP, which I'll explain in a second, every single gas in the world, if it's at SDP and we have 1 mole of that gas, it will have a volume of 22,4 decimeters cubed. Okay, that means 22,4 liters. Okay, what does SDP stand for? Standard temperature and pressure. Standard temperature is 0 degrees Celsius or 273 Kelvin. We will work in Kelvin next year. Don't stress about it. It's just a very special temperature scale. Also, it's 101,3 kilopascals or 1 atmosphere. So the atmospheric pressure you feel in Durban. Number of moles is volume that we have divided by the molar volume. Now, the nice thing with this one is you don't have to work out the molar volume like you have to do with molar mass, because it's always 22,4. So N is number of moles, volume is in decimeters cubed, molar volume is 22,4. So now what you're going to do before you move on is you're going to pause and you're going to do activity 1 on page 203, and you're going to get your answers from teams. Let's look at molar concentration. Concentration is the number of moles of solute, so the thing we divide, per cubic decimeter cubed of the solution. Okay, so solute is like dissolving sodium chloride in water. Okay, quite straightforward. Concentration, C, moles per decimeter cubed. N is number of moles. V is volume. Okay, straightforward. Like anything we've done, let's do some problems. Okay, so we also need to remember N equals M over M. So sometimes we're going to use them together. So you don't always have the number of moles, but you know the mass. So if I combine the equation I just gave you with this one, we get concentration is mass over molar mass times volume. Concentration is C, M is mass, M is molar mass, V equals volume. Alright? Straightforward. Alright. Remember, 1 millimeter cubed is 1 times 10 to the minus 6 decimeters cubed. 1 centimeter cubed is 1 times 10 to the minus 3 decimeters cubed, okay? So what you need to remember here is this means divide by 1,000. Remember, 1 millimeter is 1 centimeter cubed. 1 decimeter cubed is 1 liter. That's how I remember it, okay? So calculate the concentration of a 2 decimeter cubed solution. So that is my volume. If we have 2 grams of sodium hydroxide. Alright. So mass is 2 grams. V is 2 decimeters cubed. Mass, molar mass, 23 plus 12 plus 1. So we get 40. Because of the information I'm given, right, we substitute it in. So we have 2 divided by 40 times 2, 0,025 moles per decimeter cubed. It's quite straightforward. Now we have 4,9 grams of sulfuric acid, H2SO4. It's added to 100 centimeters cubed of water. Calculate the concentration. So mass 4,9, V is 100 centimeters cubed, but it must be in decimeters cubed, so I divide by 1,000. Molar mass of sulfuric acid, which we've done lots over the last little while, 98 grams per mole. Straightforward substitution in the equation. We put it into our calculator, and there's our answer. So there's really not too many things that are difficult about this. But now, of course, what mass, so this is little m, of phosphoric acid is needed to make up a 250 centimeter cubed solution of concentration of 0.35 moles per decimeter cubed? Write down what you know. I want little m. I know the volume is 250 centimeters cubed, so that's 0.25 decimeters cubed. Concentration, 0.35 moles per decimeter cubed. Phosphoric acid, 98 grams per mole. Concentration is mass over molar mass times volume. Okay. 0.35 is the concentration I want. Little m is what I have. And then we have 98 times 0.25. So we want m on its own, 8,858, because I'm going to take what's at the bottom of my fraction and multiply it by the 0.35. Okay, and now you're going to do activity 2 on page 203, and remember the answer is on Teams.